Now, we are not actually going to learn new things today. We're doing application today. So it's really important, as I said last week, that we actually understand what the things we're finding mean. So remind me, what does the derivative find? The equation of the gradient, all right? What does the second derivative tell us? The nature of the stationary point, right? So whether they're maximums or minimums. We're going to be using that stuff today in application questions. So let's say that the sum of two numbers, I didn't say that, is 72. What is their maximum product? So I want you to have a think for a second. What type of equation do you think I might be looking at here? If I have a linear equation, is there ever a maximum value? No. So what kind of equation gives us a maximum value? It's going to be a negative quadratic, isn't it? And it's going to give us a maximum turning point. So really, that's what we're trying to find. So if I said the sum of two numbers is 72, how do I write that as an equation? X plus Y equals 72, of course. So can I solve for two unknowns at once? Of course I can't. No. So Y is 72 minus X, is it not? Yeah. Can't I now do some substitution? So I want to find the maximum product of X, Y. But I'm going to substitute this for Y. X times Y is actually 72 minus X. So this is 72X minus X squared. You with me? So this is the equation. This is my negative quadratic. I would like to find this value here. Now, do you think I want the X coordinate or the Y coordinate of this value? Yeah, right? Because this is going to be my Y value. That's going to be my maximum value, okay? So I need to figure out what X is at this point before I can do that, correct? So how do I do that? I need to find my derivative, right? So if I find my derivative of this, what do I get? 72 minus 2x. What does this have to equal? 0. So then 2x is 72. So what's x?
76.
Oh, yeah. Sorry. Why did I write that? My brain just got weird. All right. So x is 36. So then how do I find the maximum value? What do I do next? Ooh.
Isn't that just common sense?
What do you mean?
That this sum of the maximum product you get that from halving. Like in this case.
What I'm really trying to do is show you the process of solving things. So we'll do, I'm going to.
It needs to be 36.
Well, if you want to find the maximum, it would be. You're absolutely right. Okay, so I'm going to put it back into which formula? The original, right? So I'm going to put it back into this one over here. This is before I did any deriving. So 72 times 36 minus 36 squared, and that gives me 1296. So that means this turning point is 36, 1296. So that means the maximum product of any two numbers that equal 72 together is going to be 1296. This is my solution. Make sense? All right, let's look at, I'm actually going to do question 4 because I haven't asked you to do question 4. So we're going to do that one together. So question 4 tells us that x plus y equals 3. Now that's pretty easy, and you can see that we're going to do the same thing we did before. And it's actually asking us to find the least possible value of x squared plus 14y. Okay, now we are going to do basically the same thing we did before, rearrange this and do some substitution. So I'm going to say that this is y equals 3 minus x. And then instead of y, I'm going to use 3 minus x because we can't solve for two unknowns at once. So x squared plus 14y, which is 3 minus x. We're going to use this. So x squared plus 42 minus 14x. What does this look like? This is a nice little quadratic that we can actually solve, can't we? So, well, actually, let's not do that yet. I mean, you can always complete the square. All right, but what do I want to do? Again, I want you to, this is my equation. So I want you to think about, what is this asking me to find? The least possible value means I'm finding what? The minimum turning point. Look at this. This is a quadratic, a positive quadratic graph. I am being asked to find the least possible value. So I need to find this. So how do I do that? Derive it. So dy dx is 2x minus 14. How do I find out the turning point? Make it equal 0. So then 14 is 2x. So then x is 7. So this coordinate is 7. How do I get the y coordinate? Put it into what? Into the original, which is this thing over here. So let's take this and put it in over here. So I've got, whoops, why am I writing x? 7 squared minus 14 times 7 plus 42. And if you put all of that in, you will get negative 7. So my answer is negative 7. That is my least possible value of this. So all we're doing is application. So when they're saying least possible, you're really looking for a minimum turning point. The maximum value, you're looking for a maximum turning point. Deriving it will give you the turning point, right? I mean, you don't really need second derivatives today to determine the nature of the turning point because they're basically telling you in the question. This is really just application. But if you want, you know what, let me just quickly show you how you could prove it if you needed to.
Why?
Sorry, why is y what? Because that's the y coordinate of this is the least possible value, right? So going sideways is just telling me the value of x rather than, because, how do I say that better? The value of the function is going up and down, right? So that's always going to be y coordinate. If I wanted to find out my second derivative, what's my second derivative of this? Right, because that's dy dx. 2. 2 is greater than 0. Does that make it a max or a min? Makes it a min. So if you need to do any proving for whatever reason, if you need to find out max or mins, you can always do it by finding your second derivative. Okay, we are doing 9.3 today.